Hello, this is Norman White at the Stern School of Business. I'd like to take a few minutes to talk to you about Java servlets, Java server pages, and the whole J2 extended edition environment, and why it's important and why you need to know about it. We're going to talk about applets, servlets, JSPs or Java server pages, the whole architecture environment of the Java 2 extended edition Enterprise Edition architecture, as well as Enterprise Java Beans and how we encapsulate business logic into Java objects. So let's start with applets. So applets were developed fairly early on in the history of the web. It was, since Java already existed, it was not a great deal of effort to add to browsers a whole Java virtual environment so that Java programs could be run under the browsers. So that was one early way of distributing applications over the web. So Java is an object-oriented program. It's similar to C++, supports classes, inheritance, lots of things like that. And it compiles down to a Java virtual machine object code, which is not an object code that exists on any real computer system, but is a higher level object code that can then be run fairly efficiently on most platforms. So it can be implemented in many different environments. In fact, you can run Java on almost anything these days. Interestingly enough, Java was originally designed as a machine control language way back when, but then they discovered that, hey, it's a pretty powerful language, and we can run it in lots of different places on lots of different platforms and not change either the program or even the compiled object code of the program. So when Java applets run under a browser, they run with security features that restrict what they can do, like read and write to the local hard drive, for instance. So these applets provided the first browser-side computation ability. So you can download a program to run on the user's machine under control of the browser. Pros are you can do almost any kind of computation on the browser, offloading the server. The cons is that these are pretty large programs, long download time, tricky to program, and difficult, as we'll see, to communicate with back-end server applications. Java servlets are more like server-side applets, i.e. it's Java code that runs on the server as opposed to one of the browser. Since they run on the server, just like a CGI program, their output is sent directly to the browser, and hence Java servlets can generate web pages dynamically. So servlets are Java classes, programs that are managed by a servlet container that's hosted by a web server. And servlets, these programs, are mapped to URLs by the servlet container. So when the servlet container sees a particular URL, it in turn knows which servlet should run to process that URL. So URLs are passed to an instance of the servlet. We can have multiple copies of the same servlet, for instance, which generates response content that's returned to the client as the HTTP response, similar to CGI programs, but running in sort of a special environment. Servlets receive input variables from the HTTP request. They can maintain state across invocations and have control of the content type that the server returns. This means they provide a portable, safe, efficient, and a very general mechanism for extending a web server. In fact, as we'll see, they also have major implications for scalability, since you can now have the same servlet running on multiple servers and being sent to from web servers, so we can grow an environment fairly quickly. Servlets are very powerful, but they require a programmer. Right? You need to know Java, and you have to extend the Java servlet model object to develop a servlet. So at a higher level and closer to end users, we have something called Java server pages. Java server pages provide a structural way to create dynamic textual content as an alternative to the programmatic method offered by servlets. So a Java server page is very much like PHP or active server pages. It's an HTML page with special markup that produces dynamic content. So you enter and leave the scripting environment. So we have embedded scripting statements, which are executed on the server, not on the client. So they're executed at this point on a web server or a sort of a special web server that also understands Java server pages. Very similar to the approaches we've seen in active server pages, PHP, Cold Fusion, etc. So although Java server pages looks like it's HTML with embedded Java code, actually it's implemented by a server, by a servlet. When a client accesses a Java server page, the web server sees that they're looking for a Java server page, and it translates right on the fly dynamically the Java server page into the equivalent Java language servlet, compiles that servlet, loads the servlet, and then passes the request to the servlet. So behind the scenes, even though it looks to the user that they're running a Java server page, in reality there is an equivalent servlet that's being built to handle and do what that Java server page was going to do. So you might think this is a lot of overhead, but if the servlet is already loaded, i.e. someone else has already used it, the server skips the translation, compilation, and loading. So a Java server page is simply an easy way, a shorthand if you wish, to specify a servlet that produces mostly structured data. So once the servlet is translated once, unless it's changed, it's a servlet. So you ask for the Java server page, and instead that servlet, the equivalent servlet, runs and does whatever that Java server page was supposed to do. Well, but even Java server pages demand that the page developer knows some Java. So Java server page developers, not end users per se, but developers who really know what they're doing, can use Java server pages to define new XML, or extensible markup language, tags for non-technical users to use in Java server pages. So in this case, you're actually adding new HTML-like tags to the Java server page. You're making new definitions that end users can use. And these Java server page custom tags are also expanded into Java server page scriptlets and then executed. So this is actually different than from both active server pages and PHP, is that you now have the ability in this environment to add your own tags and extend the environment to customize it for your company, for your website, for your application. Yeah, a lot of overhead, but since the Java server pages are only turned into servlets when they change, non-technical developers can make changes at the Java server page custom tag level, and they automatically get translated into Java server page scriptlets, and the whole page is translated into a servlet. So the actual overhead only happens when things change and after the first page hit to that page occurs. So actually, it isn't all that big. Yeah, completely confused, way too complex, but that's why you get the big bucks for taking courses like this. So what's the advantages over CGI, or the Common Gateway Interface? It's efficient, there's less process startup, overhead with servlets. They stay in memory for reuse. This container environment that is provided by the Java 2 Extended Edition keeps the servlets in memory, so they don't have to keep being loaded in from disk. It's convenient, has lots of built-in support for HTML forms, cookies, all the kinds of things that you normally would want to do, written in Java. It's powerful, can talk directly to the web server, share data, make database connections, save information, track sessions, a whole environment for doing things that people normally need to do. It's portable, You write once, run anywhere. So you can take the same, basically the same container and move it from a Windows system to a Linux system, for instance, and not recompile anything. And it's really inexpensive to add servlet support. This is an open source environment. It's free. So here's an example of a servlet, of what it takes to write a servlet. So here we have a servlet called some servlet. And it extends the class HTTP servlet. And so to do that, it's going to implement a get. So here's the public void do get, HTTP servlet request, and response. So all it has to do is extend these two classes to have the servlet do something. So here's a package for hello world. So here's a public class hello world, extends HTTP servlet, and all it does is say print writer out response.get writer out.println hello world. So it's going to do the get and then just writes out hello world. Not a big deal. Here's a slightly a packaging of that is going to extend HTTP servlet, but it's going to write hello www, and this time it's going to write it out as a complete HTML document. So it's going to generate begin HTML, begin head, begin title, hello www, end title, and then hello www. Seems fairly straightforward. It's just writing out everything directly back to the browser. And we can package that up and have a package that puts out the title, i.e., so now we have this new thing, string head with title, that we've created. And it's just going to put out the begin HTML, begin head, begin title, include the title, and notice that it's taking as a parameter the title string that's going to be put out. So here's how we would use that package. Hello www2 extends HTTP servlet. And now we're going to put out servlet utilities head with title, hello www. Right, so that's putting out the whole head with title and calling the title hello www, and then concatenates that with begin body, h1 hello www, end body, end HTML. Don't think you really need to memorize all of these code examples. It's just to give you an idea of what this environment looks like from, say, the programmer's perspective. So if you've followed it so far, you'll see that Java servlets allow you to write CGI-like programs in Java, but without the overhead of CGI, and with more power because it has a lot more built-in tools that come along with it. CGI is a much more general solution, but depending on what actual programming environment you're in, you have to go and find different tools and toolboxes and stuff to do what you want. So why is this any good? Is it that much better than active server pages, .NET, PHP, etc.? So one of the things that can happen here is servlets, since they're Java programs, they can generate any kind of output. So they could, for instance, stream multimedia out of a database, like YouTube, generate images, modify images. Since they're Java, it's easy for them to talk to a Java applet running on the browser, so you can have very sophisticated applications here with a Java applet running on the client side and a Java servlets feeding information to and from it from the server side. Now, there are some limitations. The Java security model only lets the browser make connections back to the server that sent it the applet. So you can't, it gets a little tricky if you want to do really complex things like sharing videos across multiple users and stuff. And servlets are not just Java applets. They're part of a complete development environment that can run anywhere. And this is called the Java version 2 Enterprise Edition. It includes servers and Java server pages and Java server tags as part of the environment. And it's become part of a standard cross-platform development environment supported by many manufacturers. Sun, now Oracle, IBM, big Java application places. So what's new here? One is the write once, run anywhere development. You can easily redistribute applications across multiple servers of any type. You can have a mixture of Windows servers and Linux servers and Sun Solaris servers serving up these servlets. There are a lot of high-level standards here that support some new technologies. It's a component-based development environment, so you can plug in things together. So it was really designed from the bottom up to be an application development environment for enterprise applications. So for really big companies, Ford Motor Company, Morgan Stanley, whatever. This is the kind of environment they might want to run in. So what does the whole thing look like? What are some of the elements of this big environment? Well, it has distributed communications, so it handles built-in networking, web access, remote method invocation, that's RMI, Corba for Common Object Request Broker Architecture, and DCOM, another standard for distributed communications. So lots of ways to move information back and forth between different servers or between browsers and servers. Has enterprise data enabling called JDBC, which is basically how you connect to a remote relational database from Java. You can, as we talked about, how you make a connection to a remote database object and issue queries. Java JDBC allows you to do the same thing. The environment also comes in with a bunch of common services. As a naming services directory that tells you where I can find applications that do certain things, activation services, messaging services, transaction services, lots of kinds of services that you need for building really, really large applications. It has enterprise systems assurance with built-in security supporting Java, because since Java runs sort of in a sandbox, because it's running in this Java virtual machine, the Java virtual machine typically has built-in security that's way beyond the security of just, say, running some code on a hardware server. Enterprise web enabling, so supports XML, Java servlets, Java server pages. And enterprise applications enabling, and this is something else that's new, and you'll see that Microsoft has copied this. Enterprise application platforms, application servers, and what's called enterprise Java beans. In fact, you can even model enterprise Java beans and build applications with these enterprise Java beans. And we'll talk about Java beans in just a second. So the idea about enterprise Java beans is that in an organization, you may have common business logic components that you want to distribute across many of your applications. What's the current price of a stock? What's the current inventory level of this part? And you can put them in these enterprise Java beans. So you then create applications by creating new types of session beans and entity beans for handling transactions. So these session beans are what controls the client to server interaction, and the entity beans are basically what encapsulates the data that you're trying to get back and forth. So instead of having to issue the SQL update command to update the inventory level for something, I'll have an entity bean and I'll just change the value of the inventory level in that entity bean, and it'll automatically generate the correct back-end database request. But because these session and entity beans are provided as part of the Java 2 Extended Edition architecture, they also inherit other things like services, including security, transaction management, and database integration. Makes them a much more secure and portable environment to build applications on top of. So here's sort of what it all looks like. On the left-hand side, we'll see clients two kinds of clients. The clients on the far left are outside the enterprise firewall, so there are maybe our customers, maybe our suppliers. Inside the enterprise firewall are other clients that maybe we know are part of the company, so they have more, they can do more things. In particular, you'll see that they can connect directly to the EJB container and do things at the enterprise bean level. Whereas the outside people connect first to the web container, which runs our servlets and Java server pages and HTML, and those servlets in turn will connect and do enterprise level applications. And on the far right hand side, you have the enterprise information system tier, which has legacy applications, has our ERP system, has our relational database management system. Nowadays may have a big data system in there, may have MongoDB, may have some other kinds of database or applications. But we're now providing an architecture that allows us to control the security at multiple levels here. So here's a not very good overview of this, but so we've got clients, and then we have different tiers, and within tiers we have a container, and then in the container we have different components to do things, and then we have protocols that go between the client and the container, and other protocols that go between the container applications and the resources. So the client protocols might be things like XML, HTTP, HTML, whatever. The resource protocols are probably things more like JDBC or remote database calls. But you can also add your own protocols within a company. So I don't know if you can read the middle of this slide, but the top one says HTML/XML over HTTP or HTTPS. That's web clients connecting directly to the web tier and doing the kinds of things that you can do on the web. The next level down is EJB clients, Enterprise Java Bean clients, and they're using different set of remote method invocations and different kinds of communications to connect to the Enterprise Java Bean tier, which has the business data, the rules and services that the enterprise supplies. And then the bottom tier, we have the Enterprise Information System clients. We're probably using JDBC kinds of connections to connect directly back into relational databases or other kinds of connections into legacy applications. So the management takeaway here is that Java servlets and Java server pages are just part of this much larger environment that can provide an integrated cross-platform, scalable, secure, robust set of industry standard systems that many people know about and run in lots and lots of different kinds of systems. But for more mundane uses, Java server pages are still simple to use and no harder or easier, actually, than active server pages or PHP. The only difference, I think, is that to use Java server pages, you've got to set up a sort of a minimal Java 2 extended edition environment, which typically means something like running a Tomcat server or a JBoss server, because there has to be a container that is going to take these Java server pages and translate them into scriptlets. It's also a little more complex, the mapping of the servlets, rather, into the URL that invokes them. But not that big a deal. The nice thing about Java server pages is you're using the services of this pretty complicated environment, and you really don't have to know any Java, or hardly any Java. So it opens up the whole web development to the full Java toolkit, including Enterprise Java Beans. Now, from a mobile environment, that means that you can make connections directly back into enterprise systems. and connect the mobile devices up to enterprise systems. So in conclusion, Java servlets and Java Beans, enterprise Java Beans, are used by many high-end websites. It's extended the web model to include tightly integrated Java applets and Java servlets. Lots of new kinds of peer-to-peer applications, especially in large enterprise systems. And it's a reason why many computer science students learn Java now. Thank you.